right, so welcome to our YouTube live event for going over questions on the Unit 2 project. I'm 2 minutes early, so I'm always afraid it's going to take me longer to get ready than it does. So I'm going to wait until 2:30. I know a lot of you are in class, so that this will be recorded for you if you're not here today. If you do have questions, just type them in. And I probably won't see them because I'm going to go away from this screen in a second, so I won't be able to see what your questions are. But when I'm done going over it, over the project, then I will be able to see it. So I'm going to go to our course page here, and I will wait 1 more minute and start right on time. It's always interesting how long a minute can take if you sit and look at the clock and wait for the end of the minute, and how little a minute can take if you're doing something interesting. It kind of works that way with aging too. When I was a kid, I remember days used to seem like they take forever, and now the older I get, the faster time goes, to where it's like each day kind of just blends quite easily into the next. All right, it's 2:30, so I will go ahead and start. I'm on our course page. I'm gonna scroll down. We passed October 5th. We've passed October 16th. Here we are to today, the 20th. So there's a lesson here, mathematical modeling. And if you click on this lesson, I just kind of want to go through this a little bit with you. I think this is some of the, the most interesting things that you can have in mathematics, is that you're trying to model something, right? So you guys get so used to there being a right answer to the math problems. If you ask to find the vertex or the max or the minimum of a parabola, you find the answer, and then you're like, oh, I have a right answer. But really, it doesn't work that way with real data. It's trying to figure out, is there a model for the data? And you're going to learn in this lesson how to use regression. And I down here talk about this a little bit, that often we have many satisfying solutions. Sorry, my computer's always dinging. We have many satisfying solutions to problems, and so you're trying to come up with one of those satisfying solutions. And I'm a big fan of basketball, and I'm a big fan of Stephen Curry. I think it's amazing what he's been able to do with his size in the NBA. So we're going to kind of go through, here's a little video, some kind of questions on it. You can go through, but what you're going to see here is that you can use, like, we could think of this as a linear model, right? It looks very, very linear, but what do we know about it? We know it's going to come back down, right? If I was thinking of this discus as going forever and ever, I'd think linear, but it's not. It's going to come back down, and it's going to do so in a parabola. And then you use your calculator or Desmos situation. So there's a couple examples here using Desmos, using your calculator. You can choose build the models. If you get stuck on it, I'll help. But this is more of what we're kind of working on here. So we're going to go to this website. So there's a little activity here, and you're going to play around with the slider here to see if you can make Steph Curry's shot go in, and you're going to come up with a quadratic function that works. And you're going to create a diagram of that, labeling the vertex, the axis of symmetry, and the solutions. Explain what the solutions mean in terms of his jump shot. Write the equation, the model in vertex and factored form. So that's the B. The A, you're going to try to write a paragraph that says, will this equation always model Steph Curry's shot? Explain why or why not, right? So really makes you show that you're thinking about what it means to have a parabola. So that's the lesson. And when you go through, you're going to upload your modeling project here. So it's going to have a place. It's the same task as I just described to you, but all written out. So if you don't want to be back in the lesson, you can see the same thing is there. And what really shows, what I'm really looking for in this, is that you fluidly move between vertex form, standard form, and factored form, and you understand what each of those forms give you. So I'm going to go back here. I can see right now it's just probably myself. I'm probably the one viewer here, but I hope this is helpful to you And if anybody does have any questions, I'll wait just a few moments here to see if I have a question. So I appreciate everybody's efforts in the course. Overall, as a group, you're doing very well. I like how you're communicating. You're sending me your questions, and we're working really well. See, I lost my viewer, so well done. All right. Send me your questions if you have them. Thanks for watching.